Hello, Prep 1. Today we are going to take a new topic, electric forces. In the previous lessons, you had known that all materials are composed of electrically neutral atoms because every atom has the same number of positive protons in the atom and the same number of the electrons that evolving around the nucleus. And when the balance between positive and negative charges is distributed, a form of electricity known as static electricity, electrostatic is produced. So, electrostatic is produced, static electricity. You know electricity, but you don't know, or maybe you don't know static. Static, it's like object in a constant case. It doesn't move. Static electricity doesn't move. Now let's play a game. Let's play a game together. Take a rod of ebonite rod or your pen, ebonite rod or your pen, and rub the end of it with a piece of wool. So take ebonite rod and rub it with a piece of wool like that. You have the rod and rub it with your piece of wool and bring the rod close to lightweight paper. You have lightweight paper, some scraps. You have some scraps here. Make the rod near to it or close to it. What will you observe? Your observation is that the paper scraps are attracted to the rod. But what is the reason for that? The paper scraps are attracted to the rod end. Paper scraps are attracted to the rod end. How that happens? You just rub the one end of an ebonite rod with a piece of wool, then bring the rod close to the lightweight paper or scraps. تمام? You will notice that the paper scraps are attracted to the rod end. Repeat this experiment using a copper rod. Using a copper rod, not ebonite. You will notice that there is no attraction between the rod and the scraps. So there is no attraction between the rod and the scraps. So it may depend on the type of the material. So the first thing we had rubbed one end of the ebonite rod with a piece of wool, then bring the rod close to the scraps. You will notice that there is an attraction between the rod and the rod end. But if you replace the ebonite with copper rod or by copper rod, you will notice that there is no attraction between the rod and the scraps. Now you will conclude that rubbing certain object with suitable material like wool, object like ebonite, gives them the ability to attract lightweight objects like paper or scraps of paper because they have been charged with static electricity. When you rub the rod with a piece of wool, it will charge with static electricity or electrostatic. So when you rub the end of the rod, this end of the rod will charge with static electricity. The electric charge settles on the surface of the rubbed part. You rubbed just this part will charged with electricity. So there were some charges here. So this rubbing, this friction, if we make it to certain object like copper, doesn't give them ability to attract lightweight object like paper scraps. But if we rub in certain object like ammoniite with a suitable matter like wool, that gives them the ability to attract lightweight. Because what? Because they have been charged with electricity. Any electricity or static electricity have been charged with static electricity. The object can be charged with static electricity can be made of electrically conducting materials like carbon, copper, iron, aluminium, and electrically non-conducting material like wood, paper, wool, silk, glass, ebonite. But electrically conducting material on the condition that the charged part is insulated to prevent the leakage of electric charges. So this part of electrically conducting materials like copper rod, it must be what? Insulated. It must be insulated with plastic or anything. So there is some plastic cover this rod or this wire, cover them. It is insulated to prevent the leakage of electric charges. Sometimes when you walk barefoot on carpet, sometimes you feel a slight electric shock when you touch a metal thing like metal door handle. So sometimes you feel a slight electric shock when you touch a metal door handle after walking barefoot on the carpet. Walking barefoot like that without wearing a shoe or anything in your foot. Sometimes you feel a slight electric shock like that. Can you give me the reason? I will tell you. Because when you touch in the handle, the charge formed on the body is discharged as a result of the friction with the carpet. So as you walking on the carpet with your bare foot, the charge formed in your body as you walking in the carpet with your bare foot, the charge will form it in your body, and then this charge is discharged when you touch the metal object or metal handle for the door. Is that clear? I hope so. If the winter had come, your mother will get out the winter clothes. Your mother will get out the winter clothes, right? Like jackets, pullovers, and when you wear it, sometimes you will hear a slight crackling. You will hear a slight crackling sound when taking off woolen clothes in winter. So when you taking off woolen clothes in winter, you will hear sometimes a slight crackling sound. Can you give me the reason? Because when you wear the woolen clothes, it will be a friction in the woolen particles. It will be a friction. This friction will form a charge. And while you taking off your clothes, this charge will be discharged. يعني ايه يا مستر؟ يعني انت لما بتلبس الجاكيت ده بيكون فيه فريكشن. الفريكشن ده بيعمل لي ايه؟ form charges. تمام؟ يبقى الفريكشن ده لما بتلبس بيعمل لي charges. طيب لما تيجي تقلع برضو بيكون فيه فريكشن. فالحركة دي في الوولينج جاكيت بتاعك ده هيحصل له ايه؟ هيحصل discharge للتشارج اللي عندك اللي اتكونت، هيحصل لها ديسشارج لما تعمل حركة تانية. تمام. فالديسشارج دي بيحصل منها ايه؟ بتسمع you will hear a slight crackling sound when you taken off woolen clothes. So when you taken off your woolen clothes you will hear a slight crackling sound because the discharging of the charge that is formed. Now we have a new concept, charging by friction or rubbing. This is the process of charging two uncharged objects. This is the process of charging two uncharged objects by rubbing or friction these two objects together. So rubbing two objects together that will cause the charging for all of them. Please focus on this activity. The first thing, when two different uncharged objects are rubbed together, when you have two different uncharged objects and you rub them together, what will happen? Electrons transfer from the atoms found on the surface of one object to the atoms found on the surface of the other object. احنا معانا اتنين object، تمام، هنعمل لهم عملية رابنج مع بعض. هيحصل ايه معايا؟ السيرفس بتاع الاوبجكت دي في اتومز، الاتومز دي عليها فيها طبعا الكترونات. الالكترونات دي هتروح للاتومز اللي موجودة على السيرفس بتاعت الاوبجكت التانية. جميل جميل يا مستر. All of these objects are charged with equal magnitude of charge, but opposite in type, because when the electrons come from here to here, this will have or positively charged. This object will positively charge it because he loses the electrons, and this who gain the electrons, this object who gain the electrons, it will negatively charge it. It will negatively charge it. So let's focus on this application. When an ebonite rod is rubbed with a piece of silk, rod and piece of silk, they will rub together. Electrons will transfer from the silk to the ebonite rod, from the silk to the ebonite rod. So the object who loses the electrons, it will positively charge it, and the other object who will gain the electrons, here is the ebonite rod, it will negatively charge it. So the conclusion is that the object that loses electrons becomes positively charged. The object that gains electron becomes negatively charged. Therefore, the silk becomes positively charged while the ebonite rod becomes negatively charged. That what I said. And now let's identify the concept of static electricity or electrostatic charges. They are the charges that accumulate on the surface of objects when they lose or gain electrons. We have two objects here. We have two objects, the rod and the piece of silk. One of them lose electrons, the piece of silk, so it will positively charge it, and the other one will negatively charge it because it gains the electrons. Let's come back to the concept. They are the charges that accumulate on the surface. On the surface we have the object, and the charges accumulate just on the surface, positive or negative, 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 just on the surface, not inside the object, just on the surface of the object. When they lose or gain electrons, this one had lose electrons, so it positively charged, and this object had gained the electrons, so it negatively charged. Let's move to the other point. There are many devices that can measure electricity, but here we study a specific type of electricity. We study the electrostatic charges, static electricity. So if you want to measure the static electricity in any object, you must have a coulometer device. So you have to use coulometer device. This device make you measure the electrostatic in the object, and its units is coulombs. So the units of the electric quantity is coulomb. So this coulomb is a unit, measurement unit, but coulometer is a device. This device, so this is the device that can help you to measure the static electricity, is called coulometer, and the unit that you use to describe the static electricity is coulomb, just coulomb. This image is for the French physicist who formulated the law describing the electric forces between charged particles, named after him Coulomb's law, also known as the inverse square law. His studies and discoveries in the late 18th century laid the foundation for the development of electromagnetic theory. In his honor, the unit of electric charge, coulomb, was named after him in his honor for his discoveries and invention. Let's move to another thing. Let's move to electrostatic series. This series is the arrangement of materials according to the easiness of losing electrons when rubbed together. The arrangement of materials according to the easiness of losing electrons when rubbed together. You already know that the more active metals is those who has the easiness of losing electrons. Easy to lose electrons. Easy to lose electrons, these metals. So I will repeat the identification for this concept again. The arrangement of materials according to the easiness of losing electrons when rubbed together. So this glass will lose electrons easy than the ebonite. The first one will lose the electrons more than any material, or easier than any material. So if we rub a glass and ebonite, the glass, it will lose the electrons, and the ebonite will gain it. Will gain these electrons. And also, if we rub a silk and a wool, the silk will lose the electrons, but the wool will gain electrons. This arrangement, yesterday I had composed a song for this arrangement of materials. Let's sing this song. So, glass, wood, leather, silk and wool, cotton, paper, ebonite. This song will make the arrangement of these elements more easy. Let's sing it again. Glass, 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 wood, leather, silk and wool, cotton, paper, ebonite. Glass, wood, leather, silk and wool, cotton, paper, ebonite. And the conclusion is that the material higher on the series, like glass, were positively charged, tends to lose electrons, so it positively charged. And on the other side, the material lower on the series is negatively charged, tends to gain electrons. Negatively charged tends to gain electrons. And now let's answer this question. What is the type of charge formed on each of piece of synthetic leather and wooden? Look at this series. The wooden is higher than the synthetic leather. So can you explain what is the charge on the leather and the wooden rod? The synthetic leather becomes negatively charged and the wooden rod becomes positively charged because the electrons transfer from the wooden rod to the synthetic leather. So the electrons will transfer from the wooden to the synthetic leather. Always the higher element lose electrons and positively charged, and the lower element negatively charged and gain electrons. So this is the answer. We will take another question. Which of the following materials acquires a negative charge when rubbed with a piece of wool? Negatively charged, it must be lower than the wool. It may be cotton, paper, ebonite. So we will choose cotton, paper, ebonite. There is no answer except cotton. So the materials become negatively charged when rubbed with wool must be lower than wool in electrostatic series, as we see, and that is cotton is lower than the wool. Can you give me the reason a single material can be charged with either a positive or a negative charge? Yes, that's right. Because what? Because this depends on the type of its rubbing material. If you rub the object with a higher material in the series, it will negatively charge it. If you rubbed it with a higher material, like what? Like we have مثلا silk. For example, we have silk. If you rubbed it with leather, the electrons will move from leather to silk, so the silk will negatively charge it. But if you rubbed it with wool, the silk will positively charge it because the electrons move from the silk to the wool to the lower material. So if rubbed with a material higher in the series, it becomes negatively charged, while if rubbed with a material lower in the series, it becomes positively charged.